Hello, my name is Sunil Bhandari. Welcome to this video presentation of my PQ magazine article called Back to Basics Financial Mathematics. Now, with this particular video presentation, I want to use the information I've presented within that particular article, but with a slant. And the slant is for ACCA Financial Management students and ACCA AFM students, the latter group who are the ones who are doing the new CBE examination. And I want to show you how you do those financial mathematics calculations using the ACCA official software, which is available by their practice platform called TestReach, and I'm going to use their spreadsheet. So I'm going to show you the calculations using their spreadsheet. And I'm going to start with compounding. So here is my compounding example. I've got present value 1000, N set at 5 years, R set at 9%, and I've then also converted that into a decimal point 0.09. So let me show you how we use what is going to be the spreadsheet software to present this particular calculation. Okay, so I press the equal sign as normal. I go to what is going to be 1000. I want to look to multiply that by. I'm simply going to put in 1.09. I could have copied in the cell what is going to be C7. I think that's easier that way, the way I've done it. You then put what is going to be to the power of, which is effectively the hat sign. I want that to year 5. Press enter. And I get the value 1538.62. 1538.62. So that is the compounding example. Okay, so discounting. So we have a discounting example here which I've set up. I've put in the columns times 0, 1, 2, 3. I've formatted my discount values to 3 decimal places. You don't have to do that. I've only done that so that it matches with the presentation, the tables. So I've gone down that route, and I've got a cost of capital of 12%. Now, I've put in the first one at times 0 equal to 1, as it is. But now, do I want to use the tables and punch in the discount factors? Yes, you could do that. However, I want to show you that by using the spreadsheet formulae approach, you can get what is going to be the discount factors for years 1, 2 and 3 quite straightforwardly. So let me open this cell up here. Let me press what is going to be equals. I'm going to do 1.12. Cost of capital is 12% to a decimal. Raise it to the power of what is going to be minus what is going to be that first year 1 there, and press equals. Press equals, pull that down, and I've formatted that already. For me, I like to format it to 3 decimal places. You don't have to look to do that if you don't want to. But let me show you the copy and paste facility on spreadsheet, which is different to the one on what is going to be Excel. So I take that, I right click copy, I leave that, I highlight that across, I then right click and press paste, and there go in those figures. And that's why it's important to use spreadsheet for practicing what is going to be your ACCA, FM and AFM questions. So that shows you discounting. Let's turn our attention to the annuity discount factor. Now, yes, you can use the tables, providing the information fits within the remit of those tables. Maximum cost of capital 1% up to a maximum of 20%, and maximum period 15 years. However, look at my example here. I've got a non-integer cost of capital. I've got a standard nice time period, the annuity starting at time period 1, stopping at what is going to be time period 5. So I want to call up the formula sheet, and there you can see the formula I'm going to use, 1 minus 1 plus r raised to the minus n all over r. So let me punch that into the cell and show you how that will present. Okay, so just got to be careful here. I press equals, I open a bracket, I take 1 minus, I then what is going to be, take what is going to be 1.0, and it's 825, what is going to be 825. I raise that to the power of, what is going to be minus 5 for 5 years. I close that particular bracket off. I then divide that by 0.0825 and I hit equals. And I get my annuity factor of 3.967. Let's just look at that cell again. There you can see 1 open bracket, 1 minus 1.0825 raised to the power minus 5. It will do that calc first. It will deduct that from 1. It will then, I then close that bracket, divide by 0.0825, get the value of 3.967. Okay, so let me turn my attention to the perpetuity, the cash flow that starts at time 1 and continues forever. Used quite a lot in business valuation questions. So let me start with the perpetuity with no growth. And you've got my example here showing a 12% cost of capital. I'll open the cell, I'll press equals, I'll press 1 divided by 0.12, enter, get the value of 8.33. Okay, what about the one where you've got annual growth rate in your cash flows? Again, very common in business valuation questions. So I'll open the cell here, I'll press equals, I'll go 1 divided by, I will open my bracket, I'll put 0.12, I'll minus 0.032, I will close my bracket, press enter, and I get the value of 11.364. Some key calculations used very much in the area of business valuations. Those are the perpetuity discount factors with and without growth. Okay, so finally on this presentation, I'm going to look at the area of delayed annuities and delayed perpetuities. I'm going to start with the delayed annuity, an annuity which is not going to commence at time 1. So I've got an illustration here where I am trying to ascertain the annuity discount factor at 12% for a cash flow going between years 6 and 10, which is clearly a 5-year period. So 2 ways to do it. Method 1, use the tables and ascertain the annuity discount factor for the first 10 years, which you can see here 5.650. Then take the annuity discount factor for the first 5 years from the tables, which is 3.605. And if I now take the difference between those two, so I'll press equals, press equals, I take the 5.65, I minus from there the 3.605, I enter, I get 2.045. So that's the first 10 years, less the first 5 years, gives you 6 to 10 years. Okay, what's the alternative? The alternative is going to help us with the perpetuity, especially the perpetuity with growth. And that is to take the fact that the discount period you're looking at is a 5-year period. You're looking at a 5-year period from 6 to 10. It commences in year 6. So if I take a 5-year discount factor and multiply it by if I take a 5-year annuity discount factor and then multiply that by the discount factor the year before the annuity commence. So I take a 5-year annuity discount factor, which commences in year 6, and then multiply it by the discount factor the year before the annuity commences, which is year 5. So if I show you that here, I'm going to go equals, take what is going to be my 5-year annuity, which I have there. I'm then going to multiply that by the discount factor the year before it commences, which I've copied in there. Press equals, and you can see I get materially the same answer. So that's the delayed annuity. Let's take a look finally at the delayed perpetuity with growth. Finally, may I deal with the calculation of a delayed perpetuity with growth, which is very popular in AFM business valuation questions, but is also creeping into ACCA FM questions, especially in Section A, Section B. So here I have an example. The perpetuity will commence in year 5 and continue forever. The annual growth rate is 2.4% on the cash flow. The cost of capital is 11%, and you notice I have printed the discount factor for year 4, the year before the growth rate commences. So the method here is I'm going to take 1 over the cost of capital minus the growth rate and multiply by the discount factor the year before the growth, the year before the growth. So let me open my cell here. So I'll press what is going to be equals. I'm going to take what is going to be 1 divided by, open the bracket, which is 0.11, the cost of capital. Deduct from there 0.024, close that off. I'm then going to multiply that by the discount factor the year before the growth commences, 0.659, press equals, get the value of 7.663. 7.663. I hope you enjoyed this video. If you need any help on financial mathematics, any help on either CIMA, what is going to be F3, ACCA FM, ACCA AFM, please do get in touch. Stay safe, stay well.